Our next topic in our unit is fractional indices. So we're talking about exponents that are fractions. So the first thing that we need to realize is that usually, so far, we have used square root of x. So just like an x has an exponent of 1 even though we don't write it, a square root has a 2 even though we don't write it. So if nothing is there, then it's a 2 because we're always taking out groups of 2 when we're taking a square root. How the fractions tie in is when we look at this, a square root can be written as an exponent that is 1/2. And there is our fractional index, okay, index. Any root of a number can be written using fractional indices. Our general rule is when you see x to the 1 over m, that means that you can write the root with an index of m. So, and we can go backwards too. If you start with a root that has a number out front, we can write that as a fraction. So you can go either way, just like we can with many of our other rules for indices inserts. So let's look at a couple examples of what this might look like. So first, if we have y to the 1/2, we've already kind of talked about this. This can be rewritten as the square root of y. And another example would be x to the 1/5. When we rewrite that, we're going to have x. We're going to have a radical. And just like when we write a square root, remember there's an invisible 2, the 5 is going to come outside, and that is going to be what root we are taking. So that would be equivalent to the 5th root. And like we said earlier, we can go the other way. So if we have the square root of 90, we can also write this as 90 to the 1/2. It's a square root, so there's an invisible 2, and that's how we get the 2 in the denominator. Another example, if we have the 5th root of x minus 2, we can rewrite this as x minus 2. This is a group. It needs to be grouped together with parentheses because right now it's grouped together under the radical. And our power that we're going to write on here is 1/5. And that's how we go in between writing things with a radical or a surd in surd form and with a fractional exponent. The other thing that we can look at with fractional exponents is when the numerator of the fractional exponent is not 1. So far we've talked about 1/2, 1/5. If we have a number, x, and we're raising it to a power, we have m over n. So now our fraction has a top and a bottom, and neither one of them is 1. This can be written, we're going to have the radical, and we're going to have x. Can be written, the n will go here, and the m comes inside. And that's how we can write our rule. And if you look at your foldables exponent, you'll know that we can also write this as x to the root of n all to the m. So either the m is outside or it's inside, but it's raised to the power of m, and the root is the surd of n. So that's how we split that up. Looking at a couple examples, we have a couple problems to simplify. So for example, we have 27 to the 2/3. We can rewrite this in a couple ways. I don't want to square 27, so I would write this as the cube root of 27 all squared. We can take the cube root. The cube root is 3. 3 we can square is 9. So 9 is the simplified version of that. Another example, let's look at 25 to the 1.5. Now this can be made into a fraction. Think about it for a minute. The fraction that can be made, this can be rewritten as 25 to the 3 halves power. And if we follow our form and put it in third form, that means we're taking a square root of 25 and then we're cubing it. You can cube it and then take the square root. You will get the same answer, but it's easier to take the square root of 25 first. So then we have 5 cubed, which is 125. Let's do one more example together. If we have 32 to the 5/3, what we can do is we can rewrite this. It would be the cube root of 32 to the 5th. Now, you have to figure out if you can take the cube root of 32. Cube root means I need a number that is exactly the same that I can multiply 3 times and get 32. Unfortunately, there is not a cube root because 3 times 3 times 3 is 27, and 4 times 4 times 4 is 64. So 32 falls in the middle somewhere, so I don't have an option to take the cube root. I do have an option to at least, I can switch the order of these and say that I need to take the cube root of 32 to the 5th. Now 32, I can multiply out 5 times. I'll let you guys do that on your own. But you would multiply out 32 5 times and then leave it under the cube root. When numbers get that big, you can really leave them in this form because it's not getting simpler after that. You're just making it more complicated with huge numbers. So this is where you can stop.